Hi, my name is Susan Mitchell, and I've created a lesson today for you on completing the square. Unfortunately, I'm not currently teaching in a formal classroom environment, so I'm unable to present the lesson to a class, which would obviously demonstrate classroom management and my rapport with students, which obviously I know that you would like to see. I hope that you'll consider my lesson and also that you'll take the opportunity to speak to either Matt Green or John Noggle from the Haverford School if you have further questions on my rapport with students in the classroom, my classroom management, my lesson variety, my use of technology, all of those questions that I know that you would like to see. I would really appreciate it if you'd speak to them about those things. I know that they would give you a good idea. Matt Green in particular, as the head of the upper school, has seen me teach many times in person. Also, I would add that as the head of the mathematics department at the Haverford School, I was given the responsibility of helping other teachers in the department create lessons, work on their teaching pedagogy, and create lessons that were effective in the classroom. So I do feel a fair level of confidence when it comes to working in a classroom, adapting to new situations, new environments, to students with different needs. So I do feel very confidently in my ability to do that. So I hope that you will consider the lesson that I've created and give me an opportunity to move forward in the process. So moving forward, we'll talk about the lesson, and you can see from the lesson plan that what I've decided to do is a lesson on completing the square. And before I start with the formal lesson, I'd like to take just a moment to explain why this is the topic I chose to teach. So last year I was working with a student as she prepared for her GCSE exams. And completing the square was one of the topics that she was given to do. And so as we're going through it, we're working on her revisions. I wasn't working with her for the entire year, only during her revision period. So we're going through this topic during revision. And so I began to ask her the same questions that I would ask a student of mine who had covered completing the square in the classroom, which was why? Why do we complete the square? Why do we need this tool? How does it help us? And she couldn't answer any of those questions. She saw it as it was something I needed to do. The instructions were to put it into this form. How do I get it into that form? I do that by completing the square. So although that was true, it didn't really have any meaning or relevance for her. And that's something that is really important to me in the classroom on a daily basis. I like to generate lessons, first of all, that have topic that builds directly. It needs to attach to something that the students have already covered, hopefully mastered. So my new topic, my new content needs to relate to something that they already know. And secondly, I like for them to create the reason why. So we've now come to this crossroads, so to speak, where we need a new tool because we need to do something that we can't do. And so if you can get, to me, that's kind of they're generating the curiosity, then they're really taking part in generating the tool, the solution, the method to getting what they want. So that is why I've structured the lesson the way I have structured it. And I would hope that it does what I believe it will do. And so initially, just on a day-to-day basis, I like to be on the outside of my classroom, welcoming my students in, right inside the door. I like to not be preoccupied with other things when my students are coming in. And so that's what I would hope to be doing. Also, it would be very normal for my students to walk in and see something on the board for them to start on. And not that they have to start before class begins, but they know where we're headed. They know what they're going to be asked to do as soon as formal class time begins. So I would have these 4 equations on the board. I would bring, as soon as class was meant to begin, I would bring their attention to that and expect them to factor the 4 quadratic equations. I would take this opportunity to do housekeeping, attendance, maybe touch base with a student who missed class the previous day, and hopefully they would be able to come into the lesson that we're doing today. So the students would be doing these in their notes, they would be factoring them, and I would add that this should be a skill. These 4 quadratic equations should not be very challenging for them to factor. They're pretty straightforward, and so they should do this fairly quickly. I would then give them the opportunity to check your answers with a neighbor. 3 to 4 minutes, 5 minutes max, I believe, for them to get these factorized and on their paper. I'm walking around, I'm chatting with students, and then I ask for people to go to the board. I see some correct answers. I say, would you like to go to the board? That your work looks really good. So after this, when we've taken the opportunity, the answers are on the board, I've given them enough time to check their work, make corrections if needed, of course, answer any questions. The next set of instructions I would give them is to now have a look at equations 2 and 4. And what I want you to do now is I want you to solve these 2 equations. Solve them. So I've changed the verb on them. Before they needed to factor. Now they need to solve. I would hope that they know what that means. But again, I'm walking around, I'm watching. Are their heads down immediately? Are a few of them still staring at the board? I don't really remember what solve means. I might make my way over to those students and say, you know, what do we do? What do we do when we're asked to solve? How is that different from just factoring? What more? And so I give them a few moments to solve. I'm not going to give the answers quite yet. So I'm not going to ask anyone to come to the board for this, but what I am going to ask them to do at that point is open up their computers and open up Desmos. And I'm going to ask them to take those 2 equations, equation number 2 and equation number 4, and I'm going to ask them to put them into Desmos in their unfactored form. So just as they were written on the board. When they see the equations, if they couldn't remember what solve meant, maybe that will prompt them. And if it doesn't, again, I'm going to be walking around, I'm going to notice, but at this point, I'm also going to start a conversation with the entire classroom. All right, now, what did we do to solve? And now that you're looking at Desmos, what are you seeing? So I'm going to probably call on a student if I've been walking around and see that they have done the correct thing. And I'm going to ask them, we're going to have kind of a mini review here because they should know that what a quadratic equation looks like, general idea, if it opens up or down. They should know that when I take an equation and I solve it, I set it equal to 0, I'm finding the x-intercepts. They're going to see that. Oh yeah, they're the x-intercepts. I remember now what to do and why. They're going to go through that. And also, the equation number 2 gives them what's called a double root. Ooh, what does that mean? So what we're going to do together is we're going to have this mini summary, all right? I'm going to remind them, what are some important points when we're graphing a quadratic equation? Well, the x and the y-intercepts. The x-intercepts you just found by that solving strategy. Where does the y-intercept come from? I'm going to remind them of where to find that in the equation. Then we're going to talk about opening direction. And so from there, I'm going to talk a little bit about the discriminant and the number of solutions. So when they solved, what happened was one of the equations factored into two distinct binomials, and the other one factored into a repeating binomial, what we call a double root. This would be a good time for me to remind them about the discriminant and what we learned from the discriminant, which is when we would have discussed if there's one double root, what does that mean? And in this situation, I'm going to say, well, what does that look like for the quadratic equation? Is that point relevant? Actually, it is. It's the turning point of that quadratic equation. So for equation 2 that has the double root, that point, that x-intercept, is the turning point. Okay, well, that's really helpful. I would talk about, if we're sketching a quadratic equation, is that an important point to have? That would be an important point to have. It's a maximum, it's a minimum, it's an important point to have when we're sketching a quadratic. At this point, I would ask them to put equation 1 into Desmos as well. Now, while they're doing this, I would go to the smartboard, put in Desmos, I'm going to put in the two other equations, and now I'm going to put in the new equation, but not quite turn it on yet. But it's going to be there ready to go. So equation 1 is another equation that has a double root. And so they're going to see this happen twice. Oh, that's the turning point of that one too. So when they recognize that for these two equations, equation 1 and equation 2, factorizing gives me the turning point. But for number 4, factoring didn't give me the turning point. Factoring gave me the x-intercepts. And so we're having this discussion about, well, wouldn't it be nice to have that turning point? Yes, that's a crucial point. We have decided that we need that point. But what do I do when I don't have a quadratic equation that gives me a double root? So what I'm trying to do is generate a desire to find a way to create their own knowledge. That would be the purpose of this. I would talk a little bit about what's special about these first two quadratic equations. Well, they're perfect square trinomials. Maybe that's a term they've heard before. Probably not a term they've remembered. It doesn't matter, but they're special. They're special. So they factor into one binomial squared. They're special. I would begin to ask, well, how could we use this knowledge to help us find a way when I don't have a perfect square trinomial? I'd take a moment here to let them discuss it. I don't think that they would come up with it. I don't think I'd be expecting an answer here, maybe, but I'm not sure that they would come up with this idea. But what I'm going to proceed to do is I'm going to ask them to treat something that's not a perfect square trinomial as if it were one. As if it were one. So the next part of the lesson would go to, at this point, I would probably say, okay, let's close the laptops now. If you were working with someone, let's come back. New content. Let's have everyone focus on the same place now and take some notes, write some things down. I would give them an example that's from the warm-up. It was not a perfect square trinomial. And I would say, okay, let's treat it as if it were. Let's treat it as if it were. So if I take x squared minus 8x plus 15, and I act like I'm going to turn that into a perfect square trinomial,